All right, so last time we started talking about set operations and Cartesian products. And we got to the point where we were looking at Venn diagrams and applying those ideas, right? Okay, there was one that we did that I want to remind you of before we move on into the last two, and that was this one right here. So one of the things that we talked about is we're going to create the diagram based on how many sets we have. However many sets is how many circles inside of the universal set. We're going to number the different regions that we have. And using those numbered regions, we're going to create our work on the side. And you're going to do this for every problem. And you're not going to see this listed if you're looking in the book in any sort of a way. Okay? There's other ways to do this. This one's just highly efficient and clean and quick and nice and all that good stuff. So this is the way that I show you how to do it. Okay? So you're going to list the numbers that are in each of the regions that's described. Then you're going to join it using whatever operation. And then at the very end, you're going to shade whatever region it is that it described. So everybody kind of remember where we were. Okay? All right. Now, we briefly made a point on this one that Tyler told me my number's wrong, right? This is actually 7. But aside from that, I think the equation part's right. Yeah? The set's right? Okay. Excuse me. So the thing that we noticed before we left last time is that this one differed from the last one in the fact that it, what? Has 3 sets. So when we're taking a look at this, we'll start with our rectangle. The difference is that since I have 3 sets, I will have 3 circles. So I need 3 overlapping circles inside of my rectangle. They don't have to be perfect, but something like that. And they start to look a little bit like the Olympic rings. Now, 3 is the most we're going to do. You don't need to know, what happens if I have 4 sets. We're not going to do 4 sets. So we're going to do 2 or we're going to do 3, and that's it. And we're going to label each of our sets, and I'm going to go from left to right, or kind of around clockwise, I guess. A, B, and C. And we have the universal set U on the outside. Now, last time, if you'll remember, we started inside of A and just kind of went across with my numbers. And I talked about the fact that you don't have to use those numbers. You don't have to put them in those places, but that's where I tend to put them. It's the same thing with what I'm going to do right now. This is where I tend to put the items. I put a 1 out here where A is, a 2 in the overlap at the top, a 3 over here in the B only circle, and then 4, 5, and 6 across the middle, 7 down here with C, and 8 on the outside part of the rectangle. If you put your numbers in different places, that's perfectly fine. Your numbers won't match up with mine, but your shading at the end will, and I'll be able to see your work and see that it's okay. All right? Now, just like in algebra, order of operations matters, which means those parentheses are where we're going to start. Even if the parentheses had been at the end, you're going to start inside the parentheses. So inside the parentheses, we have 2 different sets listed. We have set A, and we have set B. So the first thing we're going to do is we're going to list all of the numbers that are inside set A. So somebody tell me those numbers.
1, 2, 4, 5.
Thank you, Cheyenne. 1, 2, 4, and 5. All right, someone else tell me the numbers that are inside set B. Thank you, Mason. 2, 3, 5, and 6. Is everybody okay with those numbers so far? Okay, great. Next thing we do is like with our arithmetic back in 1st and 2nd grade, we draw a line under it. And then we look back inside those parentheses and see how those sets are joined. And they are joined with what symbol? What is this right here? That is intersection. Does anybody remember from last time what an intersection of sets is? Where they cross, what they have in common, right? All those kinds of ideas of them being the pieces that match up. So looking above this line at these 2 sets, where do you see what they have in common? What numbers are there? 2 and 5. You don't necessarily have to draw the circles. I'm just sort of giving you a visual. But the answer at this point right here is 2, 5. And if that were all I'd asked to do, I'd be done. But that was just the part that was inside the parenthesis, right? So we've done this first piece. The second piece is C. So I'm going to do the same thing I did just a minute ago with A and B. I'm going to list everything inside circle C. So what do I have inside of C? 4, 5, 6, and 7. And I'm going to draw another line. Because these 2 sets are also joined with an operation. What operation joins them? The union. So I'm going to take A intersect B as a set. I'm going to join it with a union with C. Now this is different. This is an intersection. This is union. What does union mean? All of it. You get everything, right? All right, this is the yours, mine, and ours of the children. This is your debt, my debt, and then this debt that we somehow just accrued by buying that house. We get it all. So we're going to list everything. So what am I going to list? What numbers?
2, 4, 5, 6, and 7.
2, 4, 5, 6, and 7, and they do not have to be in the right order, if you will. But we get to this point, we're actually done with the work part of it, but we're not done with the directions. The directions actually told me to do something else. Shade. So you're going to get, and you're welcome to use another color if you want to use a color to shade. You're welcome to shade with your pencil, but make it very clear what you're shading and what you're not. Okay, so you're supposed to be doing all your work neatly for me and whatnot anyway, but be really clear with the shading because sometimes we get a little messy. So we're going to shade 2 and 4 and 5, 6 and 7. And that's it. And once we've shaded those regions, we're done. So good? Okay, we're going to try another one. Okay, this is our last one too. How many sets do I have?
3.
3, which tells me what? I need 3 circles. And I need the 3 circles to all say what, I need them to say ABC. I mean, when you notice this number 6, you see that some of them have primes on them. I don't want my circle to have a prime on it. That means something different. Okay, so my circles are going to be the names of my sets A, B, C. They're not going to have any of the primes on them themselves. So don't sort of mislead yourself with that information. And I have U on the outside. Okay, what do I do next? Number. So I'm going to number mine the same way I always do, which is across the top, 1, 2, 3. Middle, 4, 5, 6. The bottom, 7, and the outside's 8. Okay. Once I've numbered my regions, I can actually go back and work with the sets. Now, the sets that are actually listed in the problem, and this is problem number 8. Too much copy pasting, apparently. Problem number 8. We've got set inside the parentheses, set A and set B prime, or we called it B complement. Let's start with A. What numbers do I get to list that are associated with set A? 1, 2, 4, and 5. It's easy, right? We just look inside of circle A, we write down all their numbers. B complement's not quite as clear. What does B complement mean?
All the numbers
Aren't in B. So we're looking outside of circle B. So if you will, cover up everything in here. We don't look in here, and we list everything outside of that circle. And what do we have outside of that circle? 1, 4, 7, and 8. Thank you. Draw a line. Now that I've got those individual sets still working inside my parenthesis, I look at how they're joined, and they are joined with an intersection. Intersection means what? What they have in common. And what do these have in common? 1 and 4. Okay, so let me remind you, we did talk about this last time, and I've already mentioned it briefly today, but you have to show this work over on the side. No work on the side, I take off big time points. You virtually get no credit. Okay, you have to show the work on the side with the numbers. Okay, here's 1 and 4. I need to join this set that has the 1 and the 4 with what set? C prime or C complement, yeah. All right, so C complement means everything that is not in C or outside of C. What is that? 1, 2, 3, and 8. Is everybody okay with those numbers? See where they came from? All right, I'm going to draw myself one more line. And I'm going to join the 2 sets that are between my 2 horizontal lines here. I've got a set A intersect B complement. And I've got a set C complement. And how are they joined?
intersection.
Another intersection. An intersection means what they have in common. And what do they have in common? 1. They only have one thing in common on this one. So the shading in it's pretty quick and easy, right? All we shade is this piece right here. Does that seem okay? All right.